Hi, this is question 4 from the AQA Further Pure for June 2013 exam paper. In this question we have two planes, 2x take away 2y plus z is equal to 24 and x plus 3y plus 4z is equal to 8, and we're being told that these two planes meet in a line L. For part A, we're asked to find the Cartesian equation for the line L. Okay, so in order to do this, the first thing we need to do is we need to find out the direction that the line L is going in, and we can do that by finding the cross product of the normals to both of these planes. Well, the normal to this plane is going to be 2, negative 2, 1. So let's write part A over here. Okay, so the normal to the first plane is 2, negative 2, 1. And we want to cross this with the normal to the second plane, which is 1, 3, 4. Okay, so if I find the cross product of these, the I component is going to be negative 8 take away 3, which is going to be negative 11. The j component is going to be 8 take away 1, which is 7, but it's a negative of that, so it's going to be negative 7. And the k component is going to be 6 take away negative 2, which is 8. So this here is going to be the direction in which this line L is going in. Okay, so what we now need to do is we need to work out a point that line L goes through. So any point at all that line L goes through. So I'm going to choose the point where z is equal to 0. So I'm going to let z equal 0. Okay, that means my two equations now are going to be 2x take away 2y is equal to 24. And my second equation is going to be x plus 3y is equal to 8. Okay, so if I now solve these simultaneously, so I'm going to take two lots of this equation from the top equation. So 2x take away 2x is no x, negative 2y take away 6y is negative 8y, and 24 take away 16 is 8. So that tells me that y is going to be equal to negative 1 and x is going to be equal to 11. Okay, so x plus negative 3 is equal to 8, so x is equal to 11. Okay, so that means that it goes through the point negative, try that again, it goes through the point 11 and negative 1, 0. So I can write down the vector equation of this line if I wanted to as r is equal to, and we've got 11, negative 1, 0. Plus some multiple of 11, negative 7, 8. Okay, so I'm now going to write this in Cartesian form, and I'm just going to show you how this works. So if I instead of calling this r here, if I call this and we'll call it x, y, z. And that means that if I subtract this vector from this one, I've got x take away 11, y take away, y plus 1, y take away negative 1, and z take away 0, which is just z. Well, that means that is going to be equal to lambda 11, negative 7, and 8. Okay, so these are going to be equal to each other. So what we're saying from here then is that the ratio between our x components, our y components, and our z components all have to be equal to each other. So oops, I've just spotted I've made an error here. That should be negative 11 there. Try that again. Okay, that should be negative 11 and negative 11. Okay, so what we're saying is that the ratio between our x components, that's going to be x take away 11 over negative 11, is going to be equal to the ratio between our y components, y plus 1 negative 7, which is going to be equal to the ratio between my z components, which is going to be z over 8. Okay, so that's how we go from our vector form to our Cartesian form. Okay, so that's part A completed. Now part B says we want to find the direction cosines of the line L. They're given by cos alpha, cos beta and cos gamma. So we're looking for the cosine of the angles that each of these make with the x, y and z axes. So in order to do this, we need the magnitude of this direction vector, which is going to be 11 squared plus 7 squared plus 8 squared square rooted. And then we'll start by doing that. So let's do, so we've got 11 squared plus 7 squared plus 8 squared. And that gives us 234. So it will be the square root of 234. So that's going to be like our hypotenuse. And then in the x direction, so for cos alpha, in our x direction, we're going to have negative 11 over root 234. So cos alpha is equal to negative 11 over root 234. So that's going to be the cosine of the angle that this direction will make with the x-axis. For the y-axis, so cos beta is going to be, well, that's going to be negative 7 over root 234. And finally we'll have cos gamma, which is going to be equal to 8 over root 234, and this is going to be telling me the cosine of the angle that this direction makes with the z-axis. Okay, so that's going to be our direction cosines, the exact value of our direction cosines. Okay, part 2 says show that sine squared alpha plus sine squared beta plus sine squared gamma is equal to 2. Okay, and before I do this, I'm just going to tidy up my work over here first. Okay, so for part 2, over here, right, so we're showing that sine squared alpha plus sine squared beta plus sine squared gamma is equal to 2. Well, if I look over here, I know that cos squared alpha plus cos squared beta plus cos squared gamma, well, that's going to be equal to 1. And just as a quick check, well, that's going to be 120, if I square this, 121 over 234, 49 over 234 and 64 over 234, and if I add those together I'll get 234 over 234, which is in fact equal to 1. So, well, using my trig identity, I know that sine squared theta plus cos squared theta is equal to 1. So that means that cos squared alpha must be equal to 1 take away sine squared alpha, and cos squared beta must be equal to 1 take away cos, whoops, 1 take away sine squared beta. Try that again. And cos squared gamma must be equal to 1 take away sine squared gamma. And all of that is going to be equal to 1. Okay, so we've just replaced cos squared alpha with 1 minus sine squared alpha, cos squared beta with 1 minus sine squared beta, etc. Okay, so if I tidy this up a little bit, I've got, well, I can subtract 1, 2, 3, from both sides. So that gives me a negative sine squared alpha take away sine squared beta take away sine squared gamma, and that's going to be equal to 1, 2, 3 to that way negative 2. So what we're saying is that sine squared alpha take away sine squared, plus sine squared beta plus sine squared gamma must be equal to a positive 2 as required. Okay, there you go. I hope you found that useful. Thanks very much for joining me, and I'll see you next time.